In this video, we're going to describe how the h value transforms an exponential function. So here you'll notice we have our general parent graph of y equals b to the power of x. And what we're going to do in this video is we're going to add a value up here in the exponent with x, and we call that h. So we're going to alter and add something to x up there in the exponent, and then see what happens on our graph. So here if we go into Desmos, again, notice we have the red value underneath, the red graph, that's going to stay the same. That's our parent graph. I've set b equal to 2 for the time being. And then we have the green value that we're going to transform. And notice that h is up here in the exponent with x. So h is right here. So what we're going to do is we're just going to alter h and see what happens to the graph. So notice, so I change h to be positive. The graph seems to be moving to the left. So as h became more positive, it moved to the left. And then as it becomes negative, it moves to the right. And hopefully what you're noticing is that this h value works very similarly on exponential graphs as it does on other functions. It transforms it by moving it horizontally. So it doesn't change the integrity of the shape. It stays the exact same shape, but it just moves that graph to the left if h is positive, which is kind of the opposite of what we would expect, and it moves to the right if h is negative, again, which is the opposite of what we would expect. So here, if we go in and take some formal notes on this, what I notice is that h is my horizontal change, my horizontal movement, my horizontal shift. So h describes how my graph is going to move horizontally when compared to the parent graph. Now, when h is positive, remember this was the opposite of what we expected to happen. So when h was positive, what we saw happen was we saw a movement, we're accidentally on capitalizations there, a movement to the left, which is the opposite of what we expected. So if we give an example here, if h is equal to -4, the graph would move to the left 4 units. So again, remember, this is your horizontal movement. When h is positive, it's going to move to the left, and when h is negative, it represents a movement to the right. So we're taking that whole graph and we're basically bumping it over a number of units. Again, this is the opposite of what we expected. Change that one up there too. And then if we give an example, if h is equal to 7, the graph would move to the right 7 units. So again, remember, these work the opposite of what we expect. When h is positive, it moves to the left, which is the negative direction on the x-axis. And when h is negative, it moves to the right, which is the positive direction along the x-axis. Now here we have a number of examples we're going to look at. So this first one is y equals b to the power of x minus 5. So in this example, we can say x is equal to negative, or h is equal to -5. And as a result, we know that we have a horizontal movement, and we are going to move 5 units to the right because we're going to move in the positive direction 5 units since h was a negative number. Now here we can see that h is equal to a +2, which means we're going to have a horizontal movement, and we're going to move 2 units to the left. Again, this is the opposite of what we expected. H moves the opposite. So we're going to move this whole entire graph 2 units to the left.